on a lot of research projects that they're using to monitor and manage the Red Lake water system. And so I'm going to turn it over to Shane here in just a minute. If you're in person, there's lunch over there on the tables. Feel free to grab those. If you're online, you can join us through the Facebook page, or hopefully you're on the Red Lake Nation YouTube, Red Lake Nation College YouTube page. On the Facebook stream, there'll be an opportunity for you to post comments. And after each section that Shane presents, we'll pause and we'll be able to read those questions and Shane can address those. So if you have anything online that you're interested in or you'd like to hear more about or a question, feel free to post that in the comments and we'll get to those at each section break. Shane has worked for the Red Lake DNR for 15, 20 years now. Yeah, so he's got a lot of experience, a lot of knowledge, and has been a great resource to us and our students in terms of partnerships and collaborations. So it's a really cool opportunity for us, and it's great to have him here to talk to you about some of those opportunities and some of the work that they're doing. Shane?
Thanks, Tammy. So, as Tammy mentioned, I've been with the Red Lake DNR for like 15, 20, I don't even know how many years. It's been a long time, but I'm not going to talk about myself. I'm going to talk about some water resources stuff today. So what I've got planned today is actually, because it's been such a long time since we've been here and had an opportunity to present, I'm kind of cramming 3 talks into one. And what I'm going to do is, for those who are here in person, if you have questions at any time, raise your hand, we can pause, we'll keep it kind of informal. Those online, we'll wait until we get to the end of each of those sections. But with that, we'll get started. So what I'm going to talk about first is just a really brief introduction to the Water Resources Program, who we are, what we do, the kind of different work that we're able to accomplish. And then I'm going to give you a brief history of the lake that goes back about 20,000 years, but won't take that long to talk about. And then I'm going to talk about something called paleolimnology, which is a very special kind of science that we've been using to do some work in the lake to help us develop a site-specific standard, and I'll explain what that is when we get to that point. And then finally, we're using this as a public meeting opportunity for what's called the One Watershed, One Plan, and we'll explain what that is, but at the end, we'd love it if anybody wants to provide any input toward that plan, toward priorities in the watershed, but I think it'll make more sense when we get to that. So this is just a really nice picture we took one morning heading out to sample on the Big Lake. This is from Panema. One of the perks of the job is we get to see a lot of really nice sunrises from over the water. So the Water Resources Program consists of a variable number of staff because we have some staff that come on seasonally, but we have a director, which is myself. We have 2 technicians, 2 biologists, a hydrologist. Some of these people are in the audience. I won't stand up and embarrass themselves, but we also recently have started an apprenticeship program. We have a non-point source specialist, which is someone who deals with sort of pollution problems that result from erosion and then helps fix those things. And then we generally have 2 to 4 interns, although this year I think we had like 20 interns. I don't even know. There were lots of interns. So I will get back to the internship because there are certainly going to be some opportunities for students who are interested. What do we do? I could spend a week talking about all the things that we do, but in a nutshell, what we do are all things surface water related. So we sample streams for their chemistry, their dissolved oxygen, temperature, all those sorts of things. We do the same thing in lakes, not just the big lakes, but a lot of the small lakes around the reservation. We do bioassessment. So bioassessment includes everything from fish to bugs to mussels to plants to anything living is bioassessment. We do hydrology. Hydrology is anything related to water flow and water level. And we also work on kind of the more boring policy level stuff like water quality standards, which is important but not as exciting. So I won't spend a lot of time on that. We do some stream restorations. That's what I already mentioned with the non-point source stuff. And then finally, we get to do research projects. I am not going to go through each of these individually and try and bore you guys with all of the details of what we do, but I will be talking at least about one particular research project today. So the area that we cover is actually an area much larger than just the diminished reservation. As you can see, this shows the 1863 boundary spreading all the way up into Lake of the Woods. And we actually do a surprising amount of work up on Lake of the Woods. And so that staff number looks like we have a lot of staff, but we get spread pretty thin. We have to go up. We're essentially covering an area that is geographically similar in size to West Virginia. So we're spread out all over the place all the time. Driving up to Lake of the Woods, sampling water up there, sampling all around the reservation. However, most of our focus is in this area. So this is the upper and lower Red Lake watershed. Watershed being simply defined as an area where all the water flows to one place. So any water that you see inside this boundary eventually finds its way to upper or lower Red Lake and then exits at the dam, which is located right there. And so you're going to see this map again because this is used in the one watershed, one plan. But this kind of gives you an idea of the area that we work. And you'll note that this area, a lot of this is off the reservation. We actually do a lot of work off the reservation. And the reason for that has to do with the fact that this is a watershed. So those streams all eventually flow into upper and lower Red Lake. Well, if we're interested in the water quality in lower Red Lake or upper Red Lake, we have to be interested in the water quality in those streams. So we're out collecting data every year, every summer in basically all of those streams. Just some examples of the fun work that we get to do. It's not all fun, but some of it definitely is. So that's us paddling kayaks up on Lake of the Woods. Here we have some intern, Sunny, collecting wild rice data up on Lake of the Woods as well. There's a ton of wild rice up around the northwest angle, and Sunny's been working on a project up there for us. This is one of our graduate student interns working out on the lake collecting water quality data. So in a nutshell, that's our program. And I'm not, like I said, I'm not going to get super detailed into what our program is or what it's all about. I'm now going to move into the history of Red Lake a little bit. Before I do that, did anybody have any questions, and were there any online, especially related to the Water Resources Program specifically? No? Okay, cool. So now we're going to move into the history. What you're looking at here is something called Lake Agassiz. You've probably heard of it, but if you haven't, Lake Agassiz is a lake that would have been over the top of us about 15,000 years ago. And it actually is the origin of Upper and Lower Red Lake. It's the origin of Lake of the Woods, Lake Manitoba, Lake Winnipeg. All of those lakes used to be this one lake that was constrained by glaciers. And when the glaciers melted, a lot of that water ran away, and some of those lakes stayed. The reason that's important is because we often look at Lake of the Woods as sort of a sister lake when we're thinking about the systems in Upper and Lower Red Lake. What's going on with the water chemistry, what's going on with the communities. So we look to the southern portion of Lake of the Woods to kind of see what could happen here. Jumping forward 17,000 years or so to about 300 years ago, when the Red Lake Band first moved into the area, the lakes actually looked a lot like they do today. So this is just kind of a current snapshot of the shape of the lakes. And before I get too deep into lakes and water quality, I have to mention fish. The Red Lake fishery, while we don't work on the fishery directly, we're not the fisheries program. There's a separate program at DNR that works on that. We recognize the importance of the fishery, and we're always thinking about fish in the back of our minds when we're dealing with water quality. The commercial fishery, of course, has been in operation since 1917, and it's the oldest freshwater fishery in the United States. It was really important for food source during World War I, World War II, and at that time supported 400 plus families. So we recognize it as a really important resource of the tribes. We couldn't, of course, manage a fishery without doing some water quality work. Currently, this is not history of the fishery, but currently the annual fish sales exceed several $1 million. And we know that it's really important economically, both on and off the reservation. So a lot of the work that we do, that's just kind of always in the back of our minds. We have some more historical fishing. So back to this map. Back in 1906, the Volstead Act was passed, and that resulted in a bunch of this ditching. You can see what looks like a stream, and then you can see what looks like a grid line up there. Those grids are ditches. And what was attempted back in those days was to put ditches into the peatlands north of the lake and drain all that land and turn it into farmland. And I mentioned that, or maybe I didn't mention, but European colonization of this area didn't have a huge impact on the watershed. The reason it didn't is because those ditches were largely unsuccessful. They didn't turn much of that land into farmland. So what's happened to those ditches is they've largely been abandoned. They do still have an impact. They result in spring runoff being a little bit more flashy or higher flood events than we'd like to see, and they result in having less water storage in the wetlands during drought conditions. So they have an impact. I don't want to minimize that, but we've been lucky that they were actually unsuccessful in their attempts to drain that area. I mentioned that. essentially they've disrupted lake level stability, and that's been important. In a response to that, the Bureau of Indian Affairs in 1931 put in the Red Lake Dam. So the dam that's at the outlet right now was built in 1931. It was just a stop log structure at that point where you had to like drop logs in to actually affect lake level. So shortly after that, so here it is in 1941, the Army Corps sort of took over and built it into a slide gate structure. So they were able to make it so it was easier to manipulate the level of the dam. And here's what it looks like now. This is a picture from the 40s or 50s, I believe. And so that's still what it looks like. Some interesting notes about that dam. Water level at the lake is maintained at 1,174 feet of elevation. So that's just like the goal. That's where we try to keep the lake so that it's deep enough for people to launch boats and that the communities in the lake are healthy. We're not flooding anyone out. So that's just kind of the goal. Changes at the dam really in the short term, and when I say short term, I mean seasonally, only affect downstream flooding. They don't really affect the level of the lake in that short term, like 3-month period. And the reason for that is that over a 1-month period, if that dam is wide open, it can only drop the lake by about 0.2 feet, which is like 2.5 inches. So the dam, it looks like a lot of water coming out. It's not really very much water. So we just like to mention that because people always have questions about lake level and the dam. So what does this have to do with water quality? Well, Red Lake, as a former portion of Lake Agassiz, is unique. It is a shallow, windswept, highly productive lake. So it's shallow. That means that when the wind blows across it, and because it's so big, it's able to get stirred up a lot. And so things mix really well in this lake. It's highly productive, meaning that it has high nutrient levels. We're going to find out that it has pretty high phosphorus, and it has a lot of algae. That can be good, that can be bad. There has to be a balance, but what that results in is a really productive fishery. So some of the questions that we've had are, did the ditching, that historical ditching, impact water quality? Did the damming affect water quality? How about that historical land use and the changes to land use? Did those things affect water quality? Now, before I can get to those questions about water quality, we have to get a little bit into the weeds of water quality standards. And I'm not going to go through all the details of water quality standards, but the Minnesota Pollution Control Agency has a criteria for what they call the Northern Lakes and Forests ecoregion. That's just kind of the area that encompasses the southern portion of the reservation. It does not actually include Upper and Lower Red Lake. However, the way that they've decided to assign levels to Red Lake is to take the neighboring ecoregion because there isn't a standard for that ecoregion. What you really need to know is their numbers to decide if the lake is impaired or not is phosphorus at 30 and chlorophyll at 9. So those numbers would need to be below that to meet standards. Anything above that, they would list the lake as impaired. We don't think those are appropriate for Red Lake, and you're going to see why. And you're going to see the research we did. But first, what's phosphorus? Okay, you've probably heard of phosphorus. Phosphorus is in fertilizer. It is a necessary nutrient for life. It is something we call a limiting nutrient in a lot of lake systems. Limiting nutrients are those nutrients that if you add more of them, they allow for more growth. There are lots of nutrients out there, but not all of them will result in a bunch of growth. So it's important, but it also decides sort of the amount of algae that can grow in our lakes. So you can have too much of a good thing, too much fertilizer, and you have way too much algae. And here's an example of that, not from Red Lake. I've never seen Red Lake this green. This is Lake of the Woods. But remember I said that Red Lake and Lake of the Woods, we look at them as kind of like geochemical sisters. So if this can happen in that southern basin of Lake of the Woods, this could happen in Red Lake. So we have to be vigilant and we have to pay attention to what's going on. This one, oh, yes. So it can be both. So if you look at it, sorry, the question was, are the algae in the lake found in sort of deposits or are they covering the whole lake? If you look at aerial photos or satellite photos of, say, Lake of the Woods, you'll definitely see what looks like deposits of them because the lake is so big. But typically in smaller lakes, I don't really think of Red Lake as a smaller lake, but smaller lakes, they tend to cover the whole lake. Here's an example of what an algal bloom on Red Lake looks like. You can see that it's covering all of upper and not much of it is in lower, and sometimes it's the opposite. And so usually it'll cover the whole basin because the algae sort of grow, and especially in these lakes with very mixed systems, it's going to result in the algae growing kind of at the same pace throughout the basin. So this is a false color image. So the Red Lake has also never been this green, but what this does is it allows us to see where is there an algal bloom, and we're seeing one in Upper Red Lake, and I don't actually remember when this was from, but just to give an example, like these things do occur here, but not to the extent that they happen at Lake of the Woods. So that's phosphorus. Now chlorophyll A, that's the other standard that I mentioned. Remember, phosphorus had to be below 30, chlorophyll A has to be below 9. Chlorophyll A is a pigment. It's the green part, it's the green thing that's out there, and it is a direct measure of algae because the algae have that pigment inside them. So how does water quality in Red Lake look? It doesn't meet standards. It does not meet the phosphorus standard, and it does not meet the chlorophyll A standard. However, we do not believe that it's impaired, and I'll explain why. MPCA discovered, and I have discovered in quotes here, that in 2017, Red Lake didn't meet standards. Well, Red Lake DNR has known that for 30 years because we've been collecting the data for 30 years. We know this as simply the natural background condition of the lake. I'm just going to show a couple of graphs. This one is the mean total phosphorus at one of our sites in Upper Red Lake. The text is kind of small. So across the x-axis, what you're seeing is year, and it goes back to 1996. And on the y-axis, you have total phosphorus, and that's in milligrams per liter. So when it says 0.03 next to that red line, that is the same as 30 micrograms per liter. So that red line is the standard. And each of those points, as you can see, except for a couple of them, is above that standard. And that's our data. So we know this. Phosphorus, way above, almost every year, right? Here we have chlorophyll A, displayed the same way, except the standard here is at 9. It's not at 10, or it's not at 30. Again, chlorophyll A has been above every year, forever, for 30 years. So why do we care if it gets listed by the MPCA as impaired? Well, there's a couple of reasons. One is if you list a lake as impaired, it looks like someone's not taking care of the lake, and it looks like the lake is polluted, and it's a problem lake. So it's bad optics, right? It makes the tribe look like the tribe's not doing a very good job because the tribe controls much of the area around those lakes. Also, if you do list a lake as impaired, it's sort of an official thing. It goes to the EPA, it goes on an official list, and the way to get it off that list is extremely complex. And one of the things you have to do is this thing called the total maximum daily load study. You don't have to remember that, but what that study is, they call it a pollution budget. It's a study that will tell you what's wrong with the lake and what do we need to do to fix it. Well, we already know that there's nothing wrong with the lake because we've been studying it forever, and we know that the land use in the area is so minimal, like things that would cause pollution just aren't around. And when I say pollution, I'm talking specifically about these two, the nutrients, the phosphorus and then the resulting chlorophyll A. So there'd be no way to fix it. And so we'd be up against a wall, fighting with the EPA, trying to prove that this lake isn't impaired in the first place. So what we did basically was we went to MPCA when they said they were going to list it as impaired, and we said, we don't think it's impaired. Before you list it, let us do a study to show that we're right. And so we partnered with Minnesota Pollution Control Agency and the Science Museum of Minnesota to do a paleolimnological study. What's paleolimnology? It's essentially time travel, but only time travel from a data perspective. I only see one smirk. One person watched the show. So paleolimnology, paleo means ancient. Limnology is the study of freshwater systems. And so it's basically a way of looking back in history through what is found in the sediment. And I will give some more detailed animations to show how that works. So lakes are often thought of as cumulative effects of the surrounding landscape. So what you're seeing here, the landscape feeds nutrients and sediment and pollen and all sorts of things into a lake, and water. All that water runs into the lake. The lake is the accumulation of those things. Also within the lake are organisms that live there. So on the bottom you have some diatoms and there's some algae floating around. And those communities can tell us what the lake conditions are like at a snapshot in time. Well, if the landscape changes, that also changes what goes into the lake. So it might change the amount of phosphorus in the lake. Well, that change in phosphorus might then result in a change in the amount of algae, which changes the amount of chlorophyll in the lake and changes the actual community that lives there. So you might have different diatoms and different algae and cyanobacteria and other things that live there now as a result of what's going into the lake. So we decided to do a study to find out if landscape changes such as these resulted in any significant change in water quality. Or was the water always like this? Was the phosphorus number what we consider at Red Lake DNR to be the normal phosphorus number? Was that always the normal phosphorus number? So the first step in the study was to work with the Science Museum of Minnesota and determine where are some good sites. We have really good bathymetric data of our lake, and we worked with them to figure out, well, where do we think that the sediment is going to be good to go get a core? The next step, after we identified those sites, was to go out on those sites in the winter, drill a hole through the ice, and using some specialized equipment that they've developed, we send a corer down to the bottom and take a sediment core of what's in the lake. And I have an animation to show how that works too. So first sediment accumulates, each of those layers kind of representing a different time period. We go out on the lake, we drill the hole, we lower this specialized piece of equipment down to the sediment water interface, which is just the place where the sediment and the water touch each other. And then that plunger, if you watch that plunger that's in the middle, stays right there as the outside of the core goes down, and that provides suction so that you're able to get an intact core of the sediment. And then you're able to pull it up, and it stays intact. That core is then taken back to the lab, and so this is what a real core looks like right here. So this portion of the core is the top of the core, and the top of the core would correspond to right now, because that's the sediment that's being laid down right now. And the bottom of the core represents that time before this, but you don't know the answer to what that time is right away. So you come over here and you do something called lead-210 dating, which is an isotope dating that we're not going to get into, but essentially it can tell us that if we know that this is now, we can look at the half-life and the decay of the lead-210 and figure out where is approximately 300 years or wherever we're looking for. So that's what we did with this core. And the way that we separate it out, you see here, they are peeling off 1 centimeter at a time. So each of those centimeters will correspond to a different amount of lead-210 and a different community of diatoms, because or it will result in the same community of diatoms if the water quality has not changed. So each of these little lines of diatoms is explaining or is showing us the community that's found inside that core. All right. And I didn't mention this, but the reason that diatoms are able to be used for this, they have a silica shell, which is basically glass. That glass shell is very persistent in the sediment. It doesn't break down over hundreds and sometimes thousands of years if you're in the right conditions. And so we can look back thousands of years and see exactly what was the community like 1,000 years ago, and then use that to tell us, well, then what was the phosphorus like 1,000 years ago? We didn't go back 1,000 years because we didn't need to for this project. This is what the data looks like to the paleolimnologists. I'm not going to even try and interpret this because those guys deal with this stuff. But you're basically looking at, again, top of the core, bottom of the core. This one over here represents phosphorus. This one is silica. This one is iron. Each one of these cores gets like 40 of these. They interpret them in ways that are far above my pay grade. What do we find? Well, we found that lake sediments were recovered from before European settlement in Minnesota, which is what we were after. So that's good. We were able to go back like 300 years. The diatom community has not significantly changed over this time, which is exactly what we hope to find. The diatom inferred phosphorus, which is where you figure out what was the phosphorus based on the diatom community that lives there. That hasn't changed. That's exactly what we hope to find. Some interesting things that we did find is that the algal productivity has been increasing over the past 2 decades, which is really interesting because we know that the phosphorus numbers haven't changed. So something else is driving the algal community. Also, sediment phosphorus, which becomes available during calm, warm periods, is increasing. Those calm, warm periods can potentially release more phosphorus into the system from within. It's not phosphorus coming in from farms or anything like that, but it's phosphorus that's already sitting at the bottom. And so we do need to pay attention to those things. So phosphorus levels in the lake are normal, which means the lake is not impaired. This is what it showed, and this is exactly what we were hoping it would show. The interesting thing about damming and ditching, there was no signature. We didn't find anything. There was no little blip during those time periods that would show us that anything happened as a result of those. That's good news. That means that those things didn't have a big impact on the lake. The MPCA agrees with us, so we are working together to develop a new site-specific water quality standard. So those numbers of 30 and 9 will now not be the numbers that apply to Red Lake. It will be numbers that we agree on and that the science supports. But there is this one last note, and that is that algal blooms are increasing. And so this could be a climate effect. This could be something else. We don't know. So we're going to continue to monitor diligently and try and get to the bottom of what's causing it, because while Red Lake is currently very healthy and very productive, we don't want it to start going the other way. And so that is the end of the paleolimnology portion of the talk. Does anybody have questions specifically about that? Sure. Ooh, mercury. Okay, that's going to be another talk. So the question was, there anything on mercury levels? We recently at our water resources program in the last couple of years have developed the in-house capability of analyzing mercury in fish tissue. And so we're starting to do way more mercury sampling than we ever did in the past. So we're studying not only fish tissue work, which actually Sonny is going to be working on, so maybe I'll make him present on it. And we're doing that, but we're also doing some work to find out, are those ditches that are north of the lake, are they contributing mercury at a higher rate to the lake? Because we think they might be. In fact, we think they are, because wetlands have a tendency to methylate mercury, which makes it more mobile, allows it to be flushed out of the system. And then when you have these ditches through the wetlands, the water flushes through really quickly, and it's able to carry that mercury into the lake. So we think that's further ammunition for us to justify shutting down some of those ditches. Any other questions? Okay, how am I doing? Oh, I'm just getting notifications. Okay. The next part we're going to talk about, I'm going to try and tie this all together in the One Watershed, One Plan process. So this is going to be your introduction to the One Watershed, One Plan. And I just want to let everyone know here, we're also using this opportunity as a public meeting opportunity. So we already had one public meeting for the One Watershed, One Plan. We had it in Kelliher. We did have a few tribal members show up, but we wanted to make sure that we got more tribal input to this process. And so this is also a public meeting. So we're going to be looking for input from you. Nobody's going to have to stand up here or raise their hands or anything like that, but we're going to be asking at the end of this that you maybe fill out a survey or send us a note or an email or something like that. So how does this relate to the other topics? Well, you've already seen this map. This is the upper and lower Red Lake watershed. I mentioned what a watershed is, and if you want like a better sort of physical feeling for the watershed, if you're driving to Bemidji on Highway 89, you've maybe seen up on the west side of the road, there's a sign that says Red Lake Watershed. That's like, that is right. Let's see if I can see with my, oh, wrong button. Hang on a second. My old man eyes, but right there should be where that sign is located. And then if you're north of Waskish, headed to Baudette, there's one right there. And I think we have one going west too, but I'm not exactly sure where it is on this map. So those kind of give you sort of geographical points that you can go check out and find the watershed. All of the work being conducted under this One Watershed, One Plan, which I'll explain what that is. And it's kind of convoluted, but I think I'll be able to at least explain it and summarize it. All of the work is being done within this watershed, but you'll note within this watershed, like here is the reservation boundary. And here are a bunch of those streams I talked about that flow into Red Lake. Well, if we want to protect water quality within Red Lake, we have to be engaged with our partners that are outside that reservation boundary. And so we've got Beltrami County, the Watershed District, Beltrami SWCD, and I'll mention those in the future. But those all have to be engaged if we want to be able to work in the watershed, because the watershed just doesn't care about jurisdictional boundaries. So what is One Watershed, One Plan? Okay, first off, it's a voluntary program and a voluntary plan. That was really important to the tribe before we signed on to this, before we were able to get the tribal council to support it, because the tribe doesn't want to do anything that's going to threaten sovereignty. And so it needed to be something that's voluntary and something that the tribe can walk away from at any point, and they can. It's funded, and that's really hard to see, but it's the Clean Water Land and Legacy Act. Maybe you remember back in 2009, we passed an amendment that allowed an additional 3/8 of 1% to be added to sales tax, and that money is to be used for mostly natural resource related projects, but also the arts. And so that money is used to build the plan. It's also used to do the projects. It aligns water planning along watershed boundaries. So that's what I mentioned, having different jurisdictions doesn't really work with water. It makes much more sense to plan at a watershed scale. It is all local priorities. So this is not an example where the state would come in and say, here's money, but you have to do what we tell you. This is where we get together with our partners in the watershed and decide what are our priorities, and we have to work on those priorities. And the state still funds it. It uses existing authority and funding mechanisms, and that just means that we're not like building a new board who has power or taxing authority or anything like that. It's just partners. Progress is tracked, which is good. We want to be able to track progress and make sure that we're improving water quality. And then after adopted, the partners in the watershed work to install the projects. So you go through this process of identifying needs and projects and priorities, and then everybody works together. It's kind of just, we all say we're going to play nice, and so far it's working out really well. What does the plan address? Well, obviously, if it's a watershed plan, it has to address surface water. So it addresses surface water. But also, it's supposed to be an all-encompassing plan. So if there are priorities that you're thinking of in your mind that occur in this watershed that are maybe related to habitat, that can be terrestrial habitat, it doesn't have to be in the water, or land stewardship, ditching, drainage, soil health, or groundwater, all of those things are covered in this plan. And not everything is able to be funded through that Clean Water Legacy, but just because it can't be funded doesn't mean it can't be in the plan. We put things in the plan and we go for funding elsewhere. So just kind of keep that in the back of your mind. Here are the planning partners that have signed on to the Memorandum of Agreement. We have the Red Lake Nation, that would be us. We have the Red Lake Watershed District, which already works within that watershed boundary. And then we have Beltrami County and the Beltrami SWCD. Now, if you don't know what the SWCD is, it's the Soil and Water Conservation District. They're a quiet little board who doesn't do a whole lot because they're all about soil conservation and water conservation. So you maybe haven't heard of them. But there's something really unique about the Beltrami one, and that is that they, for as long as anyone can remember, they have had a seat set for the Red Lake Nation. So there's always been a Red Lake Nation representative on that board, and that is unique to any SWCD in the state. So there's one for every single county, and Beltrami is the only one that has a tribal representative that is assured on their board. Currently, that's me. I was appointed by the council, I don't know, 11 years ago to sit on that board, and I've been sitting there ever since, bringing our water quality issues to that board. And we've lately been doing a lot more partnership and working toward a lot of water quality goals. So this is kind of the boring policy stuff, but I'll just run through it really quick. There's a few committees. So there's a policy committee. That means one person sort of from each organization gets to sort of oversee policy and rules and regulations. Here that's Al Pemberton. So he's a council member and the head of the DNR, and he sits on that committee. And those are the only people who get to vote on what they're going to do. So then there's the advisory committee. I have staff in here who are on that advisory committee. I'm on that advisory committee. We have representatives from the MPCA, from the Watershed District, from all over the place. Anybody who might have information about the projects that we want to work on sit on that committee. Then there's the steering committee, and that is Kayla, myself, a representative from Beltrami SWCD, a representative from Bowser, which is the agency that will do the funding. I don't know who I'm missing, but there's a few. And then there's the public, and this is the one I'm most interested in today. You guys are the public, okay? And anybody online, you're the public. It's really important that we hear from the public because unlike, I think, a lot of other sort of government plans, this one actually not only requires us to ask the public what their priorities are, but we really want to know what public priorities are because these are, almost all of these projects are voluntary. They're not projects that we can force somebody to do. And so we have to get public support to make these projects happen. So what happens once we complete the plan? The partners all get together and we implement the plan. So we'll have a list of maybe 20 priority projects, and we'll get together and go to the state, to Bowser, that's the agency with the money, and say, here are projects, fund them, and they'll fund them. The partnership gets that money in a non-competitive way. So we don't have to, a lot of times we have to write grants and compete with others to do projects. In this case, we don't have to. If the projects are approved, they're just approved and we just get to do them. So it's pretty great. And I mentioned having things in the plan that can't be funded by Bowser is fine because we can use the plan to go to other agencies and get money as well. And then I'm going to cover just a little bit more information about the watershed. So this is kind of what's been presented to the public off the reservation. So I just wanted everyone to see that here. The upper and lower Red Lake watershed, we all know, is in northwest Minnesota. It contains the largest lakes in Minnesota. We're pretty familiar with those. It is the headwaters to the Red River. So Red River folks are interested in what we decide to do up here because our water quality affects their water quality. It spans Beltrami County, Red Lake Watershed District, Red Lake Nation, also some other counties. So if you look on this map, you'll see Coochin County is in there, a little bit of Itasca County, but the primary staff and the primary governments that are involved are going to be from Red Lake and from Beltrami County. And that's why you didn't see Cooch or Itasca County being listed as partners. They chose not to. We've covered some of the issues and some of the concerns already. So these are just some of the ones that were talked about by the technical committee. The ditching, altered hydrology are a high priority for us already. We think that restoring those peatlands and getting rid of some of those ditches, especially those that are not providing benefit to anyone, is probably going to be important. And we've received nothing but positive comments from the public so far. Some of the water quality issues that have come up, actually a lot of these, so if you look at anything that's red or anything that's yellow on that map, that probably came from data that we provided, because we are collecting that data off the reservation to determine where are their impairments. And so it actually looks worse than it is, because some of those impairments are things that we've already determined are just natural. So we find E. coli, then we have to go in and find out where did the E. coli come from. And if it came from beavers and birds, we're not super concerned. If it came from humans or cattle, we're pretty concerned. A lot of it came from beavers and birds, so that's good. Some of the other impairments we have are biological impairments, total suspended solids, which is just like a measure of how much stuff is floating, sediment is floating in the streams, and then nutrients, of course, in lakes, which is something we talked about with the paleo stuff. Some other features that we mentioned to partners, there's a lot of wild rice within the watershed, and it maybe not as much as some other watersheds, but it's still here and it's still an important resource. There are some phosphorus sensitive lakes in this watershed, Red Lake not being one of those. The Big Bog State Park or State Recreation Area is here. There's some scientific or scenic and natural areas here. Walleye fisheries are obviously important, and a lot of these things are like no-brainers for people in this room, but for other partners who are coming in who don't always work in this watershed, it's important to bring these things to their attention. Sturgeon reintroduction, which started back in 2007, I believe, that's important to us too. So what I would like to ask of you, and I will put this back up at the very end, I would like you to either scan this QR code and consider filling out our survey to bring your priorities to our watershed planning effort, or if you prefer, there are some paper copies up here. If this one doesn't scan for you up on the screen, we have paper versions of them on the tables, and then like I said, I'll come back to it at the end. And then one other thing that I want to mention, if any of the topics that I covered today sort of gave you an inkling of interest, like maybe that might be something I'd like to do. You saw us paddling the kayaks, you see us playing out on the water, the science side of it, if anybody's interested in any of that stuff, we have a fairly active internship program. And Josh, if you could raise your hand, Josh, for those in the room, is in charge of our internship program. Some other people who are here today, Sonny over here, both of these guys started with us through our internship program. And so it's a great opportunity for you to come in and find out if you really have interest in working in natural resources, or I think as Josh mentioned to me today, like you can come in and work for us for 2 weeks and decide you hate it. And that's a great experience too, because then that's not something you like to do, right? So if you have interest in the internship program, please reach out. Doesn't have to be right now, but if you want to, Josh is here today. And with that, I'm happy to take any other questions. And any of my staff, if I miss things, jump up, tell me. Wendy. Excuse me. That's a really excellent question. And so we've been working, there's a guy at Minnesota DNR who has a lot more, I got to repeat the question for the people online, sorry. We mentioned that we have interest in removing some of those ditches or restoring the hydrology of those ditches. And how would we go about doing that? The simplest way to do that, we've got a partner at Minnesota DNR who has a lot more experience in peatlands and ditches. And so the simplest way to do that is to just plug them. Just put a plug at the end. It doesn't restore everything. It doesn't fix the peat. It doesn't fix the vegetation, but it can at least keep the hydrology at the level that it's supposed to be at so that those peatlands can slowly restore themselves. Now, when we say slowly, we mean really slowly. Some of those peatlands have been accumulating peat for thousands of years, so it's not like this is an overnight fix. it could be kind of an overnight fix to the hydrology question and to the mercury issue. And so if we're left with either do nothing or plug them, we would choose to plug them. If we wanted to get a little bit more extensive, we could go back in and we could push the spoil back into the ditch all the way through. That would restore the hydrology even better and would put that mineral soil back in the bottom. But again, it wouldn't restore the peat. And there's not really a great way to go in there and stitch in new peat. You just have to wait for it to accumulate again. So does that answer your question? Okay. That would be the simplest version, and we recognize that that is not a full restoration, but it would be better than what we have now. Any other questions? Okay, well, thank you for allowing us to come today and for listening to me drone on for 40 minutes. We hope that Josh is going to be able to come back and present for us whenever we can do this again. We'd like to continue doing this. We want to make sure that the community is hearing about the work that we're doing and has a chance to provide some input. Josh, I already forgot the name of the program. I was going to remember it, but say it again. Ajda. See, I can't do it. I knew I'd screw it up. Ajda Aguajin? Is that it? It was as close as I can get. I will get it. I promise. It's the outdoor recreation program, and yeah, he said it means let's go outside. Okay, so that I'm hoping that Josh can come back and present on that along with the internship program. And I think that if you're interested in an internship, those of you who are online, you would be well served to be here in person. You get a chance to meet Josh. You can talk to some of the other former interns, find out what it's like, find out how miserable it is to work with us. I don't think it's too bad most of the time. So anyway, with that, thank you.